Hello guys, good morning, good afternoon, as per your location, your time zones. Let's begin our today's session in which we are going to talk about basics of Selinux. Selinux actually stands for Security Enhanced Linux. So generally we use certain tools in our system to improve securities like antivirus or firewall. To make it even more stronger, on the top of antivirus and firewall, we'll apply this one more security called as Selinux. So how does it protect your environment? See, generally we have two types of security models. One is DAC and the other one is MAC. DAC stands for Discretionary Access Control, where it is not that much strong. If people are connected from outside to your system, they can go anywhere in the system. It does not have control over the people who are coming from outside or who are connecting from outside. See, generally you may have some services via which you can connect to the system. It may be FTP, it may be HTTP, it may be Samba, via which people will be connecting to your system. So once they are connected, it won't control their activities. But to make it even more stronger, we prefer to go with mandatory access control. So once the user gain access to the system, here we can control the activities of a user, like what he can do, where he can go, what he cannot do, and where he cannot go, or can he upload the data or not, can he download the data or not. Every small or big activities of a user can be controlled when they are connected from outside using different processes. See, this control is not generally for people who are directly connected. For instance, you connect to your machine by giving username and password, and you would be connected to your machine on a terminal. That's a different connectivity. Here I'm talking about people who are connected via applications like FTP, HTTP, SMTP. Using such applications, people will be connected to my system. So I want them to play in their area only. I don't want them to come out and go anywhere else, wandering in the system. So when people connected via FTP, they should be only dealing with FTP kind of thing. They should not try to gain access for other things. So that's what can be controlled by mandatory access control. And this SE-Linux comes under mandatory access control program, where the policies of SE-Linux will be applied and managed on the top of kernel. That makes it even more stronger. And these policies are going to drive the whole SE-Linux program or enforcement. So anyway, how does it control or how does it works? See, as per SE Linux, there would be two things. One would be subject and the other one would be object. So subject can be any process, FTP, HTTP, Samba, different processes or applications via which you can connect to the system. It can be even database or it can be SAP, whatever it might be. But the goal is via this subject, I want to reach out to object. Object can be any file or folder where we want to enter with the help of subject. But when we try to do an activity between subject and object, there will be Selinux Policy server, which will check according to Selinux this action is allowed or not. If this action is allowed, it will grant access. If not, it will deny, saying that you are not allowed to do this activity. So like that, every small or big action, here I have taken a small example that it is trying to reach out to a file or read a file or write a file, but it may be anything. User is trying to create another file, open a directory, changing a directory, or any actions that user is trying to perform when they are connected with an application. So that small or big thing can be controlled via SLNX. Now let's go even deeper and let's try to talk about the components and the locations of SLNX. The configuration file of SLNX is etc SLNX config, and there is a link kept in etc sysconfig Selinux. So you go to first location or second, both are same, and it will give you access to this file. Now what is the role of this file we'll understand in a short while. As of now, I'm not going to touch that. We'll come to it in a short while. Then there is something called modes in Selinux. Everything has a mode. For example, if you see an electric switch also has two modes, on or off. In the same way, SLNX also have certain modes. Three modes are there: enforcing, permissive, and disable. So enforcing, you can take it as active mode, where SLNX policies are active and they are protecting your system. Every action going on is monitored and protected by SLNX. Whereas disable is inactive. Let's say it is not at all active, no protection is going on, and it is simply disabled or inactive. So enforcing is active and disable is inactive. Between active and inactive, you have one more mode, which is permissive. Now, this permissive is not completely active, not completely deactive. You can take it as warning mode. See, in this scenario, what happens is it won't protect anything. No SLNX protection would be there. Whatever is going on will be going on without SLNX only. But instead of protecting anything, it would start giving the warnings like this shouldn't be done, or you must not do that, or this is not a valid action. Kind of warnings it is going to give. It is not going to protect anything, just it is going to do warn, and it will store the logs of the activities done with the SE Linux or what people have done against the rule that we might have created. That kind of logs would get stored. So active is completely protecting your system. Inactive is completely disabled, does not protect anything, no warning, no logs, nothing. Whereas permissive will not be active, but it will prompt warnings and store the log actions. Also, there is one more thing called booleans. Generally, we know that booleans are the variables that you can set to true or false, on or off kind of thing. Here also it is same, but booleans are small permissions or activities which we can allow or disallow. For example, user can change the directory or not. You can set it to true or false. User can upload or data or not. True or false. User can download the data or not. True or false. So every small permission we can grant or deny, such thing is called as booleans. And the major concept over here is Selinux policy. See, as the beginning of this course, the concept name what we saw was basics of Selinux. So unfortunately, we are not going to touch the part Selinux policy. Policies are very important. It is the root of Selinux or engine of Selinux that's going to drive the total Selinux workforce. There are different policies available, targeted policies, multi-level security policies, something like that, but that's very deep. And generally it is not required for us to go so deeper. See, we are going to learn here that how to drive a car. It's not necessary for me to understand how to design a car, because if I can drive a car, that's my work and I'm going to do that. Designing is not my concern or development is not my concern. So going and working with that policies may not be that much required for us as far as our work is concerned. But policies have one of the important part, which is Selinux context. See, this context are the label or permissions that we have allowed or denied via Selinux. Normally we have read, write, execute permission. Here we have some statements that may allow or stop people connecting to the file or directory when it is allocated to the file or directory. To do certain activity, to allow some action, we'll change the context. To again deny that action, we'll again change the context. So normally you can consider it as permissions. The permissions that you can allow in a Selinux can be considered as context. Contexts are a bit different from the normal permission, where you can set user role type and other things, but you can consider it as, or you can take it as permissions for a Selinux. Now let's move ahead and let's see how to work with a Selinux. So let us log in into our machine and let's see that how we can work with this Selinux. Let me also use this thing. So first of all, the question or the command what we are going to check out is how to know Selinux is in which mode. Is it enforcing, permissive or disable? So we got a command get enforce. When we run this command, it tells us that in which mode we are. Currently it is enforcing. You want to see even great details. So we can go for another command, se status. So when we run this command, it gives us even more details, like SLNX is enabled. And if it is enabled, the place where all SLNX related data will be mounted is sysfs SLNX. This is the place where the data related to SLNX will be mounted. It is not kept there permanently. It is a mount point. If SLNX is enabled, you see the data there. If it is disabled, you won't see or you won't find anything there. So all your booleans, contexts, policies will be kept at that location. The location of your configuration is etc SLNX. policy, as I've told you, is targeted. Different types of policies are there, targeted, MLS, all that thing. So let's not go into that part. Important thing what we are going to discuss is current mode is enforcing and mode from config file is also enforcing. See, the difference between current mode and mode from config file is current mode, I'll change it to anything else. If it's enforcing, maybe I'll change to permissive. But changing the current mode, does it make it permanent? No, because you have to update the config file also. If you remember in the partitioning class, we have formatted the partition and mounted. But to make it permanent mount, you have to update etcfs tab, the config file. So in the same way, I can change the current mode to anything I like, but to make it permanent, I have to update the config file. Then it becomes permanently. So current mode is enforcing, which is also permanent mode. Now let's move ahead and let's say I want to see context of a file or a directory. For instance, we have a file called file1. I want to see context of this file. According to SLNX, what are the permissions or rules assigned to it? So I'll go for ls-l. This will show me normal permissions. To this, if you just add capital Z or Z, you'll see that it will give you a different information. Like some meaning it is telling unconfigured object, something like that. So this we can understand if we know policies kind of thing. So let's not worry about that. Our concern would be this, that what type of policy is applied. So it says that the context applied is that this file can only be accessed by admin of this home directory. That means only root has access to this file. From outside with some application like FTP, HTTP, if somebody tries to access this, it will deny the access, saying that you are not allowed to access this file, even though if the file is having full permission also, but SLNX would stop it, saying that you are not allowed to connect externally if you are connecting with some applications. Similarly, there is a directory called new dir. I want to see details of that what context it is carrying. Same scenario, you have to say ls-ld followed by capital Z to see the SLNX context. So it also says the same thing, that it is also allowed to be controlled by admin home, and it's a targeted policies ending with T. Now don't worry about what is target, what is MLS and all that. For that we need again a greater detail on SLNX, which is not required generally until unless you are very uh, you know high-end kind of thing you are working, architect level or something. So as of now we don't need that, so let's not worry about that. So anyway, I want to change this context. See, there are different contexts available, and while the end of this course, you may learn many of the contexts. And mostly whenever we are going for any concept like FTP, HTTP or SAP or database, we'll have a documentations with us. So those documentations will clearly tells you that for which concept, what kind of context you got to use. So let's say that I want to use a context called public content. See, public content is very much same to 777 permission. Like when you give 777, that means you are granting full permission. In the same way, in SLNX, if any file you give public content, that means it has access from everyone, no protection for SLNX. So how to change it? Currently, if you see this file 1 is having admin home, I'd like to change it. To change the context, we got a command called chcon, change context. See, I'm trying to change the type of context. So I'll say change context, the type of context. What type I want to give, I want to make it public content. As it's a targeted value, it will again end with T. Public content T. Public underscore content underscore T. For a file, file1. Now, if any file carries this, that means it has full access. SELinux does not have any protection over this file. It's similar to 777, what we does in a normal context of permissions. Now, similarly, you got a directory, new dir. So if I say new dir, it has again the same context admin home. Does it have any files? Great. So it has some files also. So let's make a scenario like that. You have a directory who have admin home, and this directory contains files which also have admin home. So I want to change the context of this directory and all its content to public content. How to change the context of the directory as well as the contents inside it in one shot. So we'll go for chcon. As I want to go deeper inside it and do this activity, I have to use R. So I want to change the context recursively, and I want to change the type of context, which is public underscore content underscore T and the directory name new dir. The first you check the directory, it says public content. Earlier it was admin home, now it changed to public content. Similarly, if I say ls-lz, it says all the file have been changed to public content. Earlier they were admin home. So like that, you can change the context of a file or a directory with its content. See, if I wouldn't have used R, then it would have only changed the context of the directory, whereas the files would still be admin home. So that is also possible. If you want to change altogether at a time, then you better go with R. Else, do not use R. Now assume like that I have changed the context number of times. Maybe one time public content, another time some other like public content read write or samba underscore share. Different contexts are there. We are going to learn many of them in the coming time. So after changing it 3-4 times, now maybe I want to restore it back to default. I don't know what is the default value, but I want to just restore it back to default. To restore it to default, we have a very simple command, restore con. Very predictive command. It says that it is used for restoring the context. So restore con -v, V stands for verbose, which is not mandatory. If you are not interested to see output, don't add V. If you want to see the output of this command, then use V. I want to change it for file 1. Let's see that earlier it was public content. Now I'm restoring it. I'll say restore con -v file 1. So it says that earlier it was public content, which is now changed to admin home. So like that, you can change the context and again restore it back. Now same thing, I want to do it for this directory also, where this directory is having public content and the files also public content. We want to restore it all together in one shot. So we'll say restore con minus capital R. If you want to see the output, V. Not interested in output, don't use V. And the directory name is new dir. Now if you check back LDZ first, it says that it is admin home. And if I check out the contents, they are all back to admin home. So like that you can change the context and you can restore it back again by using restore con. Now let's talk about booleans, that how to change this booleans in SLNX. First of all, let's see the booleans in your system currently. So to check the booleans, we got a command get se bool. I want to see all booleans. So when I hit enter, it is going to display the booleans related to every important applications: Samba, FTP, HTTP, DNS, SMTP, SFTP, all the different applications via which we can connect to the system. Related booleans, related actions would be given, which you can control by making them on or off. So I'm not interested to see all. You see few booleans are on, few booleans are off. So I want to check booleans related to particular process or particular application. So I'll go with get se bool -a and grep out only for a particular process, maybe FTP or maybe HTTP or maybe Samba or DNS, whatever you like, you can change it out number of times. So this is how you can find out the booleans related to any particular application or important processes of your system, via which people can connect from outside and can do different tasks. Like you see, Samba users, can they create home directory or not? Can they become domain controller or not? Can we enable home directories or not? So actions what can be performed via Samba are turned out to be off or on. So if they are off, people can't do it. If it is on, then only people can do it. So I would like to change this value from off to on. To change it, we can use some different concepts. What is that? Let me explain you first. See, a boolean can be on or off. This is the criteria of a boolean. It can be on or it can be off. To make it on and off, you can use simply on or off with a command, or you can say true or false, or you can say 1 or 0. So any of these possible values you can use to make it finally on or off. Simply you can repeat on and off, or you can say true or false, or you can say 1 or 0. The end result will be on or off. Finally what it is going to display is on and off only. But to make it on and off, you can use simply on off, true false, or 1 0. Anything you use does not matter. So let me show you how to do that. For example, I want to enable a feature Samba Share NFS, which is currently off. So let me make it on. Let me say, for example, set se bool. To view the information, get se bool. To change the information, set se bool. So I'll say set se bool and the boolean value what I have copied, Samba share NFS. Now I can say on or true or 1, anything you like. For example, I'll say true. Now if we go back and check it out, you see that the value has been changed to on. Now the value what you have changed has been changed temporarily. That means now you have made it on. If system gets rebooted, it would be off again. Or assume it was already off, you made it on. So if the system restart again, it would become off. So how to make these changes permanent? Same command you have to repeat, and just by adding minus capital P will make sure that this change is persistent or permanent. So even if you reboot, see this time it is taking bit more time. So that means it is updating something in the background, which is nothing but your uh, SLNX data in sysfs SLNX. I'll take you there also. Now if you just check it out, it's now activated and it is permanently activated as we used minus "p". Similarly, if you don't want it, you can disable it as well. You can say same thing in place of true, false, or off, or simply zero, anything you like. So like that, we can make a Boolean change permanent, activating permanently and deactivating permanently. All right. Now we need to talk about context. Before talking context, let's see what are the data kept in the mount point. So if we say SE status, it says that the mount point is sysfs SELinux. Let's see what is kept inside it. So I'll go to sysfs SELinux. You'll see all the important things related to SELinux is kept here, like Boolean information or context, default context, and policies. All that thing are maintained over here. So when SELinux is active, you see the data here. If it is inactive, you'll not even find this directory SELinux in this location. Earlier, this mount point used to be very simple. In Red Hat 6 or previous version, the mount point used to be just /SLNX. But now it have been modified to sysfs SLNX. So quite some change they have brought in the mount point. Earlier it was simply SLNX. Now it is sysfs followed by SLNX. Now let's try to talk about context. So context goes like this. We have three contexts as we discuss. First is enforcing, second is permissive, and finally we have disable. See, there is a rule related to change in these modes. Anytime you like, you can change the mode from enforcing to permissive. And again, you can come back from permissive to enforcing anytime you like while the system is up and running. By passing one option, you can change the mode from enforcing to permissive and permissive to enforcing, no problem at all. But if you are going from enforcing to disable or permissive to disable, then you can't do it online. To make it disable, you have to reboot the machine compulsorily. Without this, you can't make SELinux disable. Similarly, if you want to come back from disable either to permissive or to enforcing, still you got to reboot. So whenever you are making it disable, you have to reboot. And whenever you are bringing it out from disable, still you got to reboot. So in any condition, from any mode to disable or disable back to any mode. Reboot is compulsory. Enforcing to permissive, permissive to enforcing, you can play n number of times online. But enforcing to disable or permissive to disable needs a downtime, you have to reboot. Coming back from disable to permissive or enforcing, you got to reboot. But the question arises here that why? Why shall I reboot my machine every time I'm disabling and again enabling? The answer is in our slides, what we saw at the time of discussion. See, you saw over here that Selinux policies are applied on kernel level. So if it is applied on kernel level, see, you can't remove or apply anything on kernel simply when the system is running. You had to reboot the system so that kernel can make the changes on the top of it. So you are disabling, you have to reboot. You are again enabling, you have to reboot. Then only these changes can be applied. Otherwise, it cannot be applied. And this is the reason you need a downtime. So let's see how to change these modes. So if we say get enforce, the current mode is enforcing. I want to change it to permissive. So you can use a command set enforce. So you see set enforce says you can change set enforce to enforcing or permissive. It says you can't do it disable. So you have to type the full word enforcing permissive, or there are shortcuts 1 or 0, where 1 stands for enforcing, 0 stands for permissive. So first I'll do it with full word. I'll say set enforce permissive. If you just check it out, get enforce, it says that it is now changed to permissive. Earlier it was enforcing and now it has been changed to permissive. Similarly, you want to again bring it back to enforcing. Set enforce enforcing. So you can just check it out, it is back. Or you could have simply done it with that 1 or 0 as well. Set enforce, maybe I'll use 0, it will make it permissive. Set enforce 1, it will again make it enforcing. So instead of typing the full string, simply you can use 0 and 1, that is quite oftenly used. Now, I would like to change it to permissive, for example, but this change is a temporary change. As you see, current mode is permissive and mode from config file is enforcing. That means right now it is permissive. If system gets reboot, it would be back to enforcing. So I want to make this change persistent or permanent. So I have to edit the config file. Using that -p option does not have anything in context. It's only valid till Boolean. So I got to go to the config file, which is etc Selinux config or etc sysconfig Selinux. Anyway you go, it is going to open this file. Now here you have to come and you have to change the string here. So it says enforcing is this, permissive does this, disable does this. So let me change it from enforcing to permissive. So let us come here and let's change it to disable. Now here 0 and 1 does not work. You have to type the full word. If you try 0 and 1, it's give error. So I'll say that make it permissive. Let us save and quit. Now you check SE status. It says current mode is permissive, mode from config file is also permissive. So like that you can change the mode and make it permanent. Again you can change it enforcing and update the file, it becomes permanently enforcing. Now let's see how to disable it. We don't want it, I want to disable it. So in order to disable it, we don't have any other shortcuts. We got to update the file etc Maybe this time I'll go other location, sysconfig Selinux. Either etc Selinux config or etc sysconfig Selinux. Main file is Selinux config. Sysconfig is a link file. If you check the permission, etc sysconfig Selinux. So it is a link file starting with L, pointing to whom? Selinux config. So any way you go, it is going to open same file only. Now let me come here and I'll remove that permissive and I'll type disable. Either type disable or simply copy paste the word from the above. Save and quit and just check it out. SC status. You'll see that current mode is permissive. After reboot, it is going to be disabled. Now let's reboot the machine and see what happens. Let's observe the boot process as well. We can press escape as well to see what's going on. Anyway, nothing happens even we press escape. It's just booting the system normally. Done. System got booted up. Let's reconnect. Now, if we say get enforce, it says disable. SE status disable. Try to change it, set enforce 0, it won't work. Set enforce 1, it won't work because again to bring back, you have to reboot the machine. Also, if you check it out, etc or let's say cd, etc Selinux, sys fs, do double tap. See, there is nothing with the name Selinux where all the data gets mounted. Sys fs Selinux. So even that mount point does not appear if this Selinux is in disabled state. Anyhow, now again I want to bring it back. So the procedure is you have to go to etc Selinux config. In this config file, you got to change the keyword disable to enforcing. Save and quit, or you can make it permissive either. Let's reboot the machine. See, last time when I asked it to remove the Selinux policies, abruptly it went and removed the policies very quick. But now when we are asking it to re-enable the policies, you see it is not going to happen so quickly. As the booting process starts, it waits, it warns us that I am going to relabel the Selinux policies. You see warning, Selinux targeted policy relabel is required. Relabeling could take a very long time depending on file system size and speed of hard drive. So now it is going to relabel the policies, which is going to take very long time depending on how much data do you have and what is the speed of your hard drive. So this is the reason if you are never going to implement SELinux, at the first disable it and keep it like that. But if you again want to enable it, then you have to put the data, reboot the system, and wait for policies to get relabeled. Or you could have kept it in permissive mode where it would be in deactive state only. Just it will store the logs and print warnings so that anytime you want to make it enforcing, immediately you can do without any downtime. You don't have to wait so long at the time of booting when you again enable it. See, to destroy it takes very quick time, but to again make it, it is going to take time always in any matter. So that's what it is happening here. To re-enable, it says it is going to take a very long time, and we had to wait patiently that how much time does it going to take. And one more thing, that after relabeling is completed, it is going to reboot one more time. And that time it boots normally and it comes up with uh, proper things. Okay, you see policies got relabeled and system got again restart. This time it is going to boot normally and we may not see any pause or any stoppage this time. Okay, so system got rebooted. Let's reconnect from outside and confirm. You can say uh, get enforcing SE status. It says it is also back. Checkout sys fs. Automatically a Selinux directory appear which contains all your data. So like that, you have to work with this Selinux concept, although it is basics, but this is more than enough when we are working on any environment to deal with Selinux. This thing does not replace firewall. It is not a substitute to firewall. It is not the substitute to other things. It is an additional layer of security on the top of firewall and antiviruses. They have their own role to make it more stronger. As I've told you that assume you have an office or something, so you have alarms, you have CCTV cameras, so still we need an extra layer of security, so we'll maintain a panel of security guards. So that does not mean that it eliminates firewall or antivirus. It would be there, but this will add an extra layer of security which strengthen your overall security. Meet up in the next session. It's all for today's session. Thank you.
Okay, thank you. Bye.
Bye.